Today I am starting the first topic, first unit of the 11th class, Physical World and Measurement. This one unit is divided into 5 chapters. First one is the introduction about the physics. Second is the system of the units. Third, measurement of length, mass and time. Fourth, dimensional analysis. Fifth, error of measurement. First we will start about the introduction of physics. What is physics and which topic is included in 11th class. This physics is the branch of science which tells about the natural phenomena which are happening in our nature. This one physics is divided into two types of objects. One is the microscopic, second is the macroscopic. Macroscopic object, this one is the type of the object in which we are studying about the big size, finite size of the object. Those objects which we can see, which we can observe, that type of object included in the microscopic study. And related to this type of the study is given, name is given classical physics. This classical physics, father of the classical physics, old physics, is called Newton. Second type of the physics is divided into microscope objects, that is the study of the elementary particle. Elementary particles means in which we can study about the small size particles like the electron, proton, neutron, like this, which we can't see with naked eye. This make up with this modern physics. That study of that type of the object is came in modern physics, and that modern physics is given by the Einstein. Because of first time of the modern physics, that is the given by the Einstein, and that is known as the quantum physics. After this, that we are explain about the classical physics and modern physics. Classical physics include subjects like mechanics, thermodynamics. In 11th class, this one we will study about classical physics. But in 12th class, we will study about the modern physics like this quantum theory, optics, electrostatic, electromagnetic. There we will study about the modern physics. But in 11th class, we will study about the classical physics. What is classical physics? Classical physics, that physics in which we can study the motion of the object, that object which we can see, that object which moving on the road. Like this one, vehicles, there we will tell about the distance, velocity, speed, acceleration. There our study about that type of the object included in classical physics. This classical physics include mechanics, thermodynamics. Mechanics, meaning of mechanics, that study of the moving particles, and thermodynamics, study of the gaseous system. That after this one, these both topic will come in 11th class. Now after this modern physics, quantum physics, that is given by the Einstein in 1905. In quantum physics, there is a tell about the electron, how electron is ejected from one surface to another surface. And in modern physics, explain about optics also. There in optics, there we will study about the light. And in light, we can't see, there is a small particle that is known as photon. There is a photon is moving, that's why we can see. Photon is a small particle. Then in modern physics, we will tell about the small particle that we can't see with the naked eyes. These will come in a microscopic objects domains, for example electron and proton. This one is the basic of the physics. What is physics? Physics is our natural phenomena which are happening in our nature, and this physics is divided into two parts. One is the classical physics. Classical means old physics, and second is a modern physics. Modern means that is related with the like this microscopic object that we can't see but we can observe about that object, that what is the momentum of this object, gaseous particles, that how they can move, that elementary particle we can say, that how electron is revolving around the nucleus, in nucleus which particle is lie, that study will come in the quantum physics, we can say modern physics. That's why the father of the modern physics is known as Einstein. And classical physics, mostly theory of classical physics is given by the Newton. That's why Newton is a father of old physics. That gravitational law, that apple is falling from the tree, that also given by the Newton. This also come in classical physics, because we can see apple, we can see tree, there is a not small object that we can't see, but we can see easily. That's why there is a macroscopic object, that's why we will study in a classical physics. Now next topic, your fundamental forces in our nature. In our nature, which type of the forces is lie? That you know about what is force. Force is a push or pull of any object in our nature. If any object is pushing or pulling by any object and itself, that is a force. This force in our nature divided into 4 types, that is a gravitational force, second is a weak nuclear force, third is a electromagnetic force, and fourth is a strong nuclear force. First, gravitational force. Gravitational force, what is gravitational force? That is the mutually attraction between any two objects by virtue of their masses. Forces having 2 types of the nature. One is the attractive nature, second is the repulsive nature. Attractive nature, repulsive nature. If any 2 objects come with each other, that is attractive nature. If 2 objects is going in outward direction, repelling with each other, that nature is known as the repulsive nature. So these all type of the forces in divided into 2 type of nature, that may be attractive, may be repulsive, that may be both attractive or repulsive. That is depend upon the object by which this force is acting. First, here gravitational force, that is the force acting between 2 objects by virtue of their masses. Due to their masses, if any 2 objects attract with each other, that attractive force is known as the gravitational force. And this force is given by Newton law. This force is given by Newton. That's why this law is known as the Newton's law of the gravitational. And other name you can say that universal law of the gravitation. And then according to this gravitational law, that force F is the force, G is the universal gravitational constant, M is the mass of one object, M2 is the mass of second object, and R square is the distance between 2 objects. If we are taking 2 objects whose mass is M1 and M2 and their distance is R, then their force will act, and that force will be attractive, and this force is known as the gravitational force. Then how we can find then which amount of the force will act? That we will find by using this universal law of gravitation, that is F equal to G M1 M2 by R square. Here M1 and M2 is the directly proportional to the force. If product of their masses will increase, then force will increase, and inversely proportional to the square of a distance between these masses. If distance between them will decrease, then force will increase. That is inversely proportional. How we can say inversely proportional? That is inversely proportional, that F equal to directly proportional to the M1 M2, and F is inversely proportional to the square. When we will take these 2 equations, then this formula will form. Then where G is the universal gravitational constant, that is 6.67 into 10 raised to power minus 11 Newton meter square per kg square. This one is the SI unit of the capital G. This one is a capital G, not small g. Both are different thing. Capital G is the universal gravitational constant and small g is the gravity due to acceleration. Now the property of the gravitational force. First is the nature of this force. Nature of this force is the attractive force. Second is the Attractive force means if there we will take two masses, then they will attract with each other. For example, that sun, if any if any one object we are taking above the surface of the earth, and if we are that losing this one, then every object will come toward the earth's surface. That is the attractive nature, means earth is attracting every object toward the surface, and this one is attraction only due to the gravitational force. Now second is the weak force in nature. This one is the weakest force in our nature. Weakest force, not strong force, not fastly force. This one is the weakest force, weak force. Second and third is the obey inverse square law. This one, obey inverse square law, means that force is the obey inverse of the square of a distance between two objects. Third, central force. Central force means this force will act between the center of these two objects. From here to here we will calculate this force. That's why we will take this one, central force. These are the two objects M1 and M2. Fifth is a long range order force. Long range means up to large distance we can measure it. Up to large distance this force will act. That is the gravitational force. Now next is the weak force. Weak nuclear force. This force is discovered by the study of the phenomena of the beta decay and in radioactivity. During the radioactivity, beta decay, that is discovered, that is the weak nuclear force. This one is the weakest force, and this one is the interaction between the elementary particle. Elementary particles means small particle which we can't see with naked eyes, that is the electron and protons. This force will act between like these type of the particle. Next is the properties. Now these remaining, and that is the some property are under investigation, not completely discovered, but some is given that its size is the 10 raised to power 25 times stronger than the gravitational force. This force is 10 raised to power 25 times stronger than the gravitational force. And the second is the exist between the elementary particles. Elementary particles same like electron and proton. Between these particles this one will exist. Now next, electromagnetic force. Electromagnetic force, this force will act between the charged particle. Charged particle, this charge we will denote with the Q letter, and it's that these charged particle can be moved, can be at rest. There is a two type of the nature of the charge. If charge will be at rest, then this force is known as the electrostatic force. That force is known as electrostatic force when charge at rest. And this force we can calculate by using this one, F equal to K Q1 Q2 by R square. Q1 Q2 is the charge of charges on the two charged particles, and second is the R square. R is the distance between two charged particles, and K is a constant whose value is 9 into 10 raised to power 9. Second, we are talking about the electromagnetic force. Electromagnetic force, that is the word come from the electron plus magnetic, that this force will act when charge will be in motion. When charge will be in motion, then electric field will act as well as magnetic field will act. Both field will act, then force is known as the electromagnetic force. That condition, that is the electromagnetic force will act only when charge will be in motion. Motion can be uniform, can be non-uniform, but if charge will be at rest, then we can't say that their force will be electromagnetic forces. Now property, that force can be attractive, can be repulsive, that if we are taking two charges Q1 and Q2, and here we are taking, then these charges can be attract, can be repel. This is the depend upon the nature of these charges. Second, obey the inverse square law. It will obey inverse square law, that is the force will be inverse to the distance of between charged particle. Central forces, that is the central forces, this force will act along the center of the charged particle. Fourth is a short range order, that means this force will act up to the short range. Fifth, property, this one is the stronger, 10 raised to power 36 times stronger than the gravitational force. This is the comparison from the gravitational force. Next, last strongest force, strong nuclear force. That force is a bind neutron and proton together inside the nucleus. Inside the nucleus there is a, what is nucleus? There is a proton plus neutron, and outside electron is revolving. That is the composition of the atom, this one atom. Then this force will act between the proton and neutron, because there is a positive charge here, negative. If they can attract with each other, then electron will fall inside this one and they can go outside. But this one is impossible, because there one more force is active, that is the strong nuclear force inside this nucleus, and this force is known as a strong nuclear force. Property, this one is a basically in attractive nature. Second is the strongest force in nature. Shortest range order, up to short distance it will act, does not depend on the charge of the nucleon. And next is a non-central force, doesn't depend upon the center of the charge particle. Now last is the strength of the all type forces. This is the comparison of the strength of all forces. Force of gravitation, if we are taking 1 strength, then force of weakest force we are taking strength 10 raised to power 25 times of the gravitational force. And third is a force of electromagnetic force, then their strength is 10 raised to power 26 times of the gravitational force. And fourth is the strong nuclear force, that is the strength we are taking 10 raised to power 38 times of the gravitational force. Now this one is a last topic. Now next we will start tomorrow.